Well, let's take a look at the hydrolysis of nitriles. So again, this can occur under acidic or basic conditions. So the idea here is that we start off with a nitrile, and here we'll just call this mild conditions. That'll form the amide, and then often what we do is we use heat here to indicate that this reaction should continue on, right, to form the carboxylic acid. All right, so it says here again, more vigorous conditions required to convert the amide to the carboxylic acid. And again, just side note on that too, right, we saw that in our last lecture here too, right? Amides under acidic and basic conditions can require vigorous conditions, right, such as heating. So, right, a little bit of heat in here helps that reaction occur also. So, let's take a look at the overall reaction down here below for acidic conditions. So, we're going to start off here with a nitrile. So, an R carbon triple bonded nitrogen. Okay, and again, for our first case here, it's acidic conditions, so we're going to have H3O plus here. And so with H3O plus, as we've done before, we're going to just treat that as H plus and H2O. Okay. Well, the first thing that happens here when you take this group, right, again, starting with your nitrile, is you're going to come around and you're going to protonate that nitrogen with a lone pair at the end. That's a Lewis acid-base type reaction. So that'll give us our R carbon triple bonded nitrogen and an H with a plus charge there. And of course, this has resonance, right? So plus resonance. You can draw that out if you like. Now what we're going to do next is we're going to go through here and we are going to add water to this. Now when we add water, let's think about where it's going to go. The water's going to come around and grab a hold of that carbon right there. And then we're going to do this. So what that's going to give us is our carbon with an O, H2 on it from water, right? A double bonded nitrogen with a lone pair and an H atom on it. And then we're just going to move in a forward direction here. So we're going to deprotonate this, and we're going to do that by using a molecule of water. So swing around and grab that hydrogen, and then voila. And that gives you your R group, your COH, and then your nitrogen with your H group, just like so. Now we know that in the end we're going to make a carboxylic acid, or at the very end, along the way, we're going to make an amide. So in order to do that, we need to convert this into a carbonyl. So that has to somehow become a carbonyl, and then that needs to become an NH2. So we need to gain some H's on there, on the end of this thing. So we're going to come down here, and we're going to grab an H from H plus and H2O. So we're swing around here and grab that H. All right, so you can see where we're going to go with this. Here's our OH group. Swing that H around. And now we're going to have a double bonded carbon, nitrogen with a plus charge, just like so. So this has resonance. And in fact, here we want to draw them out. And part of the reason is because it's going to lead us to what our next step is. So that would be our first resonance structure. So here you get RC, right, OH. Now you have an NH2. Well, that's getting closer, right? We just need to have that carbonyl. So we took care of that NH2 there, right? Now we just need this to become a carbonyl. Well, look at the next step. So go through and draw the next resonance. That is going to tell us what our next step is, right? So that gives us our carbon, double bond oxygen H, and then our NH2 here. So in this case, it's important to draw the resonance because again, it kind of leads you right in the right direction for your amide. So we're going to go over here now, and we're going to grab water, and we're going to swing that around and grab that H, just like so. That'll give you your carbonyl and your NH2. So, and you've converted that nitrile into your amide. Now, remember we said that going to the amide was milder conditions. Now, if the conditions originally were more vigorous, and we'll indicate that in our class by adding heat, then this reaction would not stop here at the amide. What would happen is we would take this intermediate, and that intermediate would react further. So let's just make a note here. This reacts further if heat is involved. Okay, so what I want to do here is this, and I think this will make the most sense. So I'm just going to draw a line right here. And then let's just take that on and imagine that we have heat present. So if so, what I want to do is I want to take one of these resonance structures. So for this, I'll take ROH plus NH2. All right. And again, plus its other resonance structures that it's bringing those along with it, right? So plus resonance. So again, now I would just to clarify that again. So if heat is present, this reaction would continue. And if it continues, remember, we're making the carboxylic acid. So what we're going to do here is we're going to add another water molecule. So water is going to come around here and add to that position. So that'll give us our carbon. That's your OH, right? Your NH2 is still the same. And here we have that so commonly seen OH2 plus group. So the idea here, the game plan, is to take care of that, deprotonate this, and then turn this NH2 into a good leaving group, and then we're just about done. So to do our deprotonation down here, we have water. So water is going to come around and grab one of those H's. That'll give us our kind of our amide hydrate, you could call it. Okay. And then this is going to get protonated. So again, we have our H plus and H2O here. So we're going to come around and grab that H. The students sometimes say, well, why can't it grab an H at this position? Well, it can. These reactions that we see here in the first few steps are really reversible reactions. Okay, so what we're going to get here is our R group, our carbon, OH, OH, NH3 plus. Right, and then we're going to take a set of electrons from one of these oxygens, and we're going to do this, and then we're going to boot off that NH3. So as we do that, we'll curve down here. So here is NH3, right? That's our leaving group. And then we're going to have our R group, our carbon, plus charge, and then our OH down there. And then again, plus resonance. Okay? And now we're just one step away, you can see here, from our final product. So not too hard, right? So we're going to come around and grab this H right there, and then do that. And that'll give us our R, carbonyl, OH, and then of course you have NH3 in here. So now you have your carboxylic acid. Now, under basic conditions, we see the same type of pattern going from the nitrile with milder conditions to form the amide, and then upon more vigorous conditions such as adding heat, we take it to the carboxylic acid eventually after an acid workup? Well, let's take a look at this reaction under basic conditions. So we're going to go through here. We have hydroxide present. So the first step here is hydroxide. Going to come around here and grab a hold of that carbon. Lone pair comes on to our nitrogen. So that's going to give us an RCOH and then a double bond nitrogen with a minus charge down here at the end. Now, again, that's an aqueous solution. So next thing that happens here is we're going to grab a proton from our water. So we're going to do this. That'll give us our R group, our OH group here, and our nitrogen that's been protonated. Now we're in a basic solution, so what's going to happen now is that hydroxide is going to come around and grab this H and do this. That'll give us an R carbon, the minus charge there, and a nitrogen and an H. Now this has resonance, so we're going to take a second. We're going to draw the resonance structure of this. So as we draw that out, we'll kind of come down and do that. It really leads us to our last step to form the amide. So that's going to give us an R. There's your carbonyl, right? Here's your H and your minus charge there. So again, there's your resonance structure, that. And then coming down here below to our last step here, we're going to grab a proton here. So this is our last step to form the amide again. So we're going to swing around here and do this. And then that's going to give us our R and H2. So here is our amide. Okay, so then I'm just going to do this because we went through this mechanism in the last lecture. So take a look at that last lecture there for amide hydrolysis, but with heat present. Right, hydroxide under aqueous conditions, right? Eventually that reacts on through that mechanism. So just look at that last mechanism. It reacts and it gives us this, right? And then that can easily be turned into the carboxylic acid by an acid workup. So sometimes you'll see this written out a couple of different ways. So I just want to show you ways in which you might see this. So let's take a look here. So you'll see maybe what I'll call the two-step method. So the two-step method would take your nitrile, right? And then with hydroxide here and our aqueous conditions, that would give us our amide, and then hydroxide with heat here would give you your carboxylate, right? And then there's the one-step method. That one-step method would take your nitrile, and then you'd have OH minus, right, aqueous, and then also notice heat, so we'll add heat here. So with that heat, then you just skip this little intermediate and you would become the full carboxylate then, right? And that's similar to the same idea, I should say, here. Okay, so same idea, not exactly the same, but the same idea is having the nitrile with H3O plus in heat. So with H3O plus in heat, that's going to give you your carboxylic acid there. So kind of two different ways that you'll see this given to you as far as solving problems. And again, it depends on textbooks, but following our textbook, which is Wade, this is kind of like the idea there.